We're now moving on to three really important rules, and they are the product rule, the quotient rule, and the chain rule. Okay, so first, the product rule. Basically, the derivative of the product of two functions is going to be the derivative of the first function times the second function plus the first function times the derivative of the second function. Okay, so this is not at all obvious, and it certainly isn't the case that to take the derivative of the product of two functions, you just multiply their two derivatives. Okay, it's more complicated than that. This will be one of the rules that I derive using the limit of the difference quotient in the very final video, and so you can see why this is equal to that. It's not obvious, so you have to know the rule and you have to use it correctly. So let me just try several examples here of how this works. So let's say I want to find, we can just say f of x is equal to, let's just say x squared times cosine of x. Okay, so this is the product of two functions, x squared and cosine of x. So if I want to take the derivative, then I need to take the derivative of the first function, x squared, so that'd be 2x, multiply it by the second function, cosine x, and then I need to take the first function, which is f of x, which is x squared, so I take the first function, multiply it by the derivative of the second function. So the derivative of cosine x is opposite sine x. So it would look like this, and then I suppose we can simplify this a little bit by bringing the negative out like this. And so we would get this. So the derivative of this is equal to all of that. Okay, so oftentimes the derivative can be fairly complicated. So let's try another one. Let's say we want to find the derivative here of I don't know, we could say the natural log of x times x cubed, let's say. Okay, well, if we want to find the derivative of this, then we're going to take the derivative of the natural log of x, which is 1 over x, times the derivative, or times just x cubed, x cubed. Okay, so the derivative of this times the function, plus the function times the derivative of that, of x cubed. Okay, so it's the derivative of this times that function, this function times the derivative of that function. It would look like this, and then we could simplify this into just x squared plus natural log of x 3 times x squared. And I suppose we could have put that out front, would have been, doesn't matter. It's okay like that. But that's the idea, okay? So let's try another example here. Let's try the following. I'm going to take, I want to do, this will just be interesting here. I'm going to do x squared plus 2 times, we'll say 2x minus 1. Okay, and I'm going to find the derivative two ways. Okay, the first way is I'm going to use the product rule on these two. So it'll be the derivative of this, which would be just 2x, that constant would go away, times that, 2x minus 1, plus this times the derivative of that. So it'd be x squared plus 2, and then the derivative of this would just be 2. So you would get this, okay? And I'm going to leave a little space here, and I'll show you why in a second, okay? So now I'm going to find this derivative in a second way. I'm going to multiply these two together. So if I do the the first two, I'm going to FOIL them. So if I multiply those together, I get 2x cubed. And then multiply these together gives me negative x squared. And then multiply the inner two, that's the outer two, the inner two would be plus 4x. And then the last two would be negative 2. And now I'm going to find the derivative of this, not using the product rule, but just of each term. Okay, so I'll take the derivative of that. That would give me, the power rule would give me 6x squared. Okay, and then this would be minus 2x. This would be plus 4. And then this would be, that minus 2 would just go away. So this and this are the same, should be the same if the product rule really works. So let me simplify this and see what we get. So this would be 4x squared minus 2x. And this would be plus 2x squared plus 4. Okay, and now these two can be combined, and I would get 6x squared minus 2x plus 4. And so we see that we get the same thing using the product rule on this, or if we multiply them together and then use the power rule, we're going to get the same thing. Kind of validating that product rule. It's kind of neat to see that. So let's try another example. Let's do, we'll do f of x is equal to, let's say the cubed root of x times e to the x. Okay, well this would be x to the 1/3 times e to the x. So that's a product of two functions, so I'm going to take the derivative of the first function, which is 1/3 x. When I subtract 1, I get negative 2/3. Okay, plus this function, x to the 1/3, times the derivative of e to the x. Sorry, I took the derivative of this one times e to the x, so I would get e to the x there. Okay, and then that function, and then the derivative of e to the x would just be e to the x. And so I don't know, we could rewrite this 1/3 x to the negative 2/3 plus x to the 1/3 times e to the x. So I could factor out the e to the x, and I suppose I could put these over a common denominator or something, but that's good enough. So you don't have to simplify these derivatives. You know, the product rule, you can get a big messy thing. You can keep it. What you do with the derivative depends on what you're using the derivative for. Oftentimes we're trying to find when the derivative is equal to 0, because that's when the graph has like a horizontal tangent line, right? And so that's where the graph makes a turn, and that's where maximum values and minimum values occur. So what you do with the derivative oftentimes depends on whether you're wanting to find when the derivative is 0, if you're wanting to do something else with it. So as you're learning to take the derivative, just do the rule, and that's good enough. You should be just fine when you do the rule. Okay, now let me do, maybe I'm going to do this on, well, I'll do it here. So let's say my function f of x is, we can say, we'll say x squared times cosine x times e to the x. And the point here is I'm now multiplying 3 functions together. So how are we able to do this? Well, here's where I find some of the notation, the Leibniz notation useful. So let me explain what I mean. So what I need to do is I need to have two of these together. It doesn't matter. I could do these two and then e to the x, or I could do x squared and these two. So let me do x squared as one function and this is another function. And so what I'm going to do is I'm going to take the derivative of x squared and get 2x times this whole thing. So that'd be cosine x e to the x. Okay, then I'm going to do plus, now it'll be this function, x squared, times the derivative of that. So sometimes I find it helpful to write this like this. So it's the derivative of this times this function plus the function times the derivative of this function. And so if this one is more complicated, instead of trying to do it all at once, then I can pause and ignore all this and just calculate this derivative here, and then just have that in a parentheses. Okay? And so that's helpful. For this one, it might have been easy enough to just do it, but oftentimes I find this sort of notation helpful. And I'll show you other examples too. So here I'm going to write this again, 2x cosine x e to the x plus x squared, and then I'm going to take the derivative of this. So it'd be the derivative of cosine, which is negative sine x, times e to the x, plus cosine x, and then the derivative of e to the x is just e to the x. So it would look like that. Okay, and then I don't know, I might simplify this like this. Cosine x e to the x, and then maybe I could pull out the e to the x, and then I'd get x squared e to the x, and then inside parentheses, maybe I'll commute those around because of the negative in front of the sign, cosine x minus sine x. And you could do that if you wanted to. You could even pull the e to the x out of both of those, or what. It doesn't matter, but this is good. Just cleaned it up a little bit. But that's the idea of the product rule. Okay? So you're basically, to find the derivative of a product, you find the derivative of the first function times the second function plus the first function times the derivative of the second function. So now in the next video we'll look at the quotient rule.